So we're going to cover how to find the factors of a number. Factors are just whole numbers that divide evenly into another number. And you can find factors by finding all the times tables that equal that number. So as you can see, these are all the factors of 72, and they all can be shown using the times tables that equal 72. And we can also see how all these numbers divide evenly into 72 with no remainder. So I'm going to show you a quick way on how to find the factors of any number. So for the method I'm going to show you, we're going to make a list, and there are 3 basic steps that we're going to follow. First, we're going to start at 1 and see if it can go into the number evenly. Second step we're going to follow is we're going to keep going up by 1 until we get a times table that repeats itself. And finally from there, once we get the repeat times table, we're going to write the factors from our list. Let's get into an example. Let's start by finding the factors of 40. So what we're going to do is we're going to start at 1 and we're going to keep going up until we find a times table that repeats itself. The thought process is going to be on the left side. The actual list you make is going to be on the right side. So let's go ahead and get started. So does 1 go into 40 evenly? It does. It goes into it 40 times. We'll put that on our list, 1 times 40. Let's go up to 2. Does 2 go into 40? It does. It goes into it 20 times. So we're going to put that on our list, 2 times 20. How about 3? Does that go into it? Nope. How about 4? Does that go into 40? Yes, it does. It goes into it 10 times. We're going to put that on our list. How about 5? Does that go into 40? It does. It goes into it 8 times. We're going to put that on the list. How about up to 6? Does that go into it? Nope. How about 7? Nope. How about 8? Yes. 8 goes into 45 times, but notice we now have a repeat times table. 5 times 8 and 8 times 5. So now we can stop the list. So now we have all the factors of 40, and the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. Let's move on to the next example. So there's actually a second point in time that you can stop the list, and you can also stop the list if you get a times table that uses the same 2 numbers, such as 6 times 6 or 9 times 9. Whole numbers that have times tables like this are called perfect squares, and you can see some of them in the top left corner of the video. So what we're going to do is we're going to cover an example of a perfect square. We're going to find the factors of 100. Let's get into it. So does 1 go into 100? It does. It goes into it 100 times. We'll put that on the list. How about 2? Does that go into 100? It does. It goes into it 50 times. We'll put that on the list. How about 3? Does that go into it? Nope. How about 4? It does. It goes into it 25 times. We'll put that on the list. How about 5? Does that divide evenly to 100? It does. It does it 20 times. We'll put that on the list. How about 6? Nope. 7? Nope. 8? Nope. 9? Nope. None of those go into it evenly. How about 10? Yep. 10 goes into it evenly 10 times. We'll put that on the list. Now we have a times table that uses the same 2 numbers. We can stop the list. The factors of 100 are going to be 1, 2, 4, 5, 10, 20, 25, 50, and 100. So the reason you can stop at a pair that uses the same 2 numbers is because right after it, the repeat times table will show up. So if we had kept going, you would eventually run into 20 times 5, which is the repeat times table of 5 times 20. So in general, whenever you see a pair that uses the same 2 numbers, you can stop because the repeat times table will show up right after it. And that's how you find the factors of any number. Now that we're done, you can do something more useful with your time, like get back to work. Come on, man, you've done like 1 problem for homework. Get it together. Like and share. Math on the fly. Laters.